So let me see if I have my chat open here. Okay, Vasavi is not able to hear me. Okay. Permission for what? Permission for what? Should I unmute you? Is that what you're saying? Summary sheet of what we have learned, right? If you see, let me just walk you through the outline first, right? You have algorithm, we talked about pseudocode, we talked about algorithm complexity, right? So I generally, when I do these things, I start putting notes there, right? So later, but you can see I put some notes, some examples, and then I put some questions, right? On purpose, I leave a few things blank. The reason is I want this to be a collaborative effort, right? I want students to go fill in those things, some of them. And what exactly we're measuring. Like somebody posted a question about, they sent me an email talking about the dependence of an algorithm on hardware and compilers and things like that. So here are some notes on that. Okay. We talked about space complexity, time complexity. I gave you definitions in the slide deck. You have them. You can, this should give you an opportunity to go and review the slide deck and fill in those blanks as to what space complexity and time complexity are. Okay, so there's no spoon feeding per se, right? So this is your opportunity to go review the stuff. We talk about asymptotic behavior. So what does it mean? So I give you some explanation there. Something on the big O notation. We talked about the big O notation, some examples, right? Big omega, big theta, small o, okay? So I came up to that. I did not really put anything in divide and conquer yet. I will do so. Maybe by the time we come to the next class. But in the meantime, you can use this as a template to start making your own notes. Okay, and then today's chapter would be on greedy method. This is where we'll get into, if you look at unit 3, this is what it says, right? These are all the problems that the unit 3 discusses. There's a couple of other things. So we'll make some progress on the greedy method today. Now, assuming it's still the same format as to that I'm supposed to be giving you the exam, writing out the exam. In my exams, I allow open book. So this summary document would come in handy for you to do well on the exam. Okay. Vasavi, I hope your audio problem is solved. And I hope all others are able to hear me. Yes, in the chat window. So I covered the material uploaded. I covered the Word document that I put. What I do when I do these things, I spend a lot of time and I collate them together. There's no reason for us to do everything from scratch in today's world, right? So I take from Berkeley notes, some other people's notes that I know of, and things like that. And after you read the Word document, if you have any questions, by all means post them in the community. One other thing that I need to mention, there was a student who sent me some questions, but I think that student also posted them in the community, and I saw some other professor answer them. That is the advantage of being in the community, right? So I don't have to be the only one answering. Post them in the community. When you get questions, post them there. And then I'll monitor them there better. And then you're not relying just on me. Someone else can also answer your questions, whether it's your peers or whether it is your faculty members. Okay, great. So in case you're wondering if this, of all the courses in computer science curriculum, the most interesting and the most challenging oftentimes is the design and analysis of algorithms. Majority of the people say that, but I would say it is really not an impossible course, and you are able to easily do the course just fine. So I just wanted to choose an appropriate quote related to this class today and to motivate you for next week. Okay. I expect the class average to be around above 70% next week when you all take the tests, even possibly above 80% too. So, okay, let me move this stuff here. Okay, so let's begin with a warm-up exercise, okay? So this is going to be a little bit interactive and methodical because cursor to your midterm exam. Remember, I told you I would prepare you for the midterm just fine. Don't worry too much about it, right? Once you know what the format is and all that, it becomes easy and it builds your confidence. So let's look at this warm-up example, okay? When the nature of interactivity here is, let me see, I want to just quickly randomly go to each of these windows here and ask you a question. And you have 15 seconds to 30 seconds to answer the question. If you don't, I would just move on. So that way the time is not wasted and other students. Unmuting SVCW. I see them. Wow, SVCW, a lot of people came. I'm very impressed. A lot of students there. What does the code do? Please put it in under everyone. In the tab there, gone past that question, what does the code do? Yes, it finds the largest number in the array. The second question that I'm asking is to everyone, anyone can answer. How many fundamental instructions this piece of code executes? Okay. Vasavi is saying it is doing a comparison, okay? Comparison is 1, but how many total from variable m equal to a0 to all the way? How many total instructions are there? The very first line I told you there are two instructions. Okay. Stab at it, JNTV or Aditya or JNTU Kakinada. Comparison is another instruction, that is 3. Okay. What about the for loop? In the for loop, are there any instructions? Is the question not clear or people are thinking? In the midterm, these are the type of questions that I would be asking, by the way. Okay. Okay. So let's move on. The way you count is right. When you have m equal to a0, you count that as a of 0 means it's a subscript, correct? So that means you have to go get the value at the subscript. That is one activity. Then the assignment is another activity. Two instructions right there in line 1. In the for loop, you have to do the assignment at the beginning of the loop. That is another one, 3, right? And then you have a comparison operator, 4, right? Okay. Loop, there are 2 more instructions, right? So that makes it what, 6? And in essence, correct? Okay, we'll see. I'll give you the solution in a second. Going to the third question. 3 instructions. Somebody said 3 instructions. Is it 3 or 6? We'll find out. 3, yes. The first line is 2. In the for loop, where you have to initialize the variable, that is 1. And then comparison I less than n is another 1. So that makes it 4. We'll come to plus plus I later. 4. And you are inside the loop. Right? Depending on the comparison, you may execute m equal to ai or not. And then you go back to the for loop, you do a plus plus again. Right? So it could be 6. We'll find out. Okay. Now let's go to the third question. Write fn ignoring the for loop body for now. Remember we talked about the big O. Big O is what fn. What is the order of fn, right? So the fn ignoring the loop body is nothing but you have the exact match here, right? So you have 2 before the for loop. You have 2 before the for loop. We are ignoring the body of the for loop, right? We are only ignoring the body, but we are taking the first 2 instructions in the for loop statement. So 2 plus 2 equal to 4, right? Fn, if you ignore the for loop body, I'm ignoring the for loop body, meaning pretend that that body does not exist. So it's an empty for loop. So the value would be 4. Now, if you consider the loop body, then you have to assume that you go into the loop and you count the number of instructions that are executed. So if you go here, I just went to the next slide to show you the answers. Okay. So you got the first 2 here. The first 2 is the variable m equal to a0. Then the next 2 is within the first statement, variable I equal to 0, right? And then after you finish that, then you have the comparison operator and then the increment operator for the first statement. The fn is 4 instructions plus 2n. Because 2n you cannot avoid because you're going through that loop n number of times. And then every time you go through that 2 instructions that you have to do that because you have to do the increment and then you have to do the comparison, right? So n times 2 is 2n. Okay. Now, if you consider the loop body now, how do we know what is fn? Right? Is there any dependency on the type of input? Because it depends on how many times the for loop is executed, right? Depending on the input array. If I'm doing an array of which is sorted 1, 2, 3, 4, right? Then you have to do it 4 times, right? Because you have to compare every loop element. If I do that in the reverse order, I may have to do it only once or 0 times. So it depends on the input size. The worst case is n, right? So that's how you come up with the worst case F1 as 4 plus 2n plus 4n, because you have to do 4n times. Okay. Let me pause here. So what I basically did here was to show you when you are given a piece of code or an algorithm, this is like pseudocode, right? For small samples, right? I can ask you the same set of questions. What you see here in the bullets would be the same set of questions. There is no hidden surprises in the test. I would give another code sample for you, and then I would ask you to write down the answers for these things. Now, would I get is there one right answer or many right answers? There are many right answers. It really depends on how you break down a line, whether it is 1 instruction or 2 instructions. In some languages, it could be considered 1 instruction. In some languages, it could be considered multiple instructions. A case in point would be whenever you're doing an array assignment, internally, if you do the array assignment in a programming language like C does not do array bounds checking internally. Okay, it's up to the programmer. So if you have to write the right program, you have to write array bounds checking code yourself. To write that code. So the number of instructions, depending on the language, compiler, machine language, instruction set, it could vary, right? So, but when I give a piece of code like that and ask you to analyze it, I'm looking for your thought process as opposed to the 100% exact answer, right? So if you, based on your thought process and your assumptions, if your answer is right, I'm going to give you full points. Okay. Let me pause here. Any faculty members are welcome to make some comments, provide some insights here. Okay. Now there's a tutorial that I'm going to upload to, which explains these answers in more detail for you. Okay. So you can see here the worst case in this case is 4 plus 6n. That is the worst case scenario. So the different techniques. We talked a lot about sorting algorithms, insertion sort, quick sort, and all of those things. Those were to sort some numbers. Then we talked about quick, what do you call it, the binary techniques of trying to find a number, right? And then we talked about merge sort last time. Now we are getting into more algorithms, and one such group of algorithms are called the greedy method. So the focus would be on understanding what greedy methods are and where they are used. Dijkstra's shortest path algorithm that uses, for example, a greedy method. So we'll look at what are all the issues that come with the greedy method and how different people have come up with the variations of the greedy method. Okay. So what we do typically whenever you want to solve a problem, it requires a set of decisions. Okay. Now, in the case of a greedy method, what you try to do is you optimize it locally. That's what it says. Each decision is locally optimal. Okay. The intent being, after you start optimizing it locally, That is the intent of the greedy method. Sometimes this works, but quite often it does not work. Greedy method is not really the most optimal way of doing it. Okay. Let me go to the. Okay. So here is a very simple example. I have not posted the slide deck yet. I will post it after the class, as I always do. Okay. So you want to pick some number of numbers out of n numbers. Okay. So you are given an array of n numbers, and you want to pick k. K is obviously less than or equal to. K numbers is out of the n, right? K is less than or equal to n. Okay. So what is the algorithm to do that? Okay. So you are basically saying for I equal to 1 to k, because you want to pick k numbers, you want to get the largest number and delete the number from the input. Because you're done with that number, then you go and pick the next number out of that array. Now, since if you are a programmer, you should always be you in your mind you're already thinking, oh, array of numbers. If the array of numbers is an unsorted array of numbers, and every time you have to go pick the largest number, that means you need to run some kind of a sort algorithm k times on the array. Either sort or at least find the max. You don't have to really do the sort, but you have to find the max. Okay. Some other programmer might say, let me sort the array first, and then simply do a sum of the first k numbers of the array. Sort in descending order, of course, right? So these are all the thoughts that should be coming into your mind now. Many ways of solving a problem, right? Another one. Here is another shortest paths on a graph. So you have when you're a computer science person, one of the things that you would encounter is graphs, right? Everything is drawn in terms of graphs, trees, and things like that. So you should be comfortable with these things. Okay. So here is a nice picture which shows, what does it show? It's showing a vertex V0 and vertex V3 at the right end. And I want to find the shortest path. So obviously it is 1, 2, and 4. That makes method here. Because there's a unidirectional path here, you're always taking the shortest route, right? And then when you go to V1, you take the shortest route. That's the greedy, right? Greedy means trying to minimize the work. So here you are taking the shortest route. Okay, now let us stretch the same problem to this one. I expanded that graph now, where instead of having just one vertex, in stage 1, you have multiple vertices. Apply the greedy method. From V0, we go to V1, right? Via the second branch, because that gives you the shortest one, right? V0 to V1 is the one path. And from there you go to the other shortest one. So you add up all of those things going from V0 to V3, it's coming to 23. Remember, the greedy method is basically always picking the lowest unit of work, or the lowest number in this case, right? The lowest weightage in this graph. Now we all know with simple math that optimal V1, V2, Aditya, I just muted you. Were you trying to say something? So what is a greedy method? Greedy method is you are making decisions. Aditya, I muted you. Put it in chat if you have a question. Okay. Okay, 1, 2, 3, 4, right? 1, 2, 3, 4. That's why you see if to V1, you can reach through those 4 branches. And then because your algorithm is greedy, it'll take the lowest one. So it takes the path of V12. So it came to V12. Now from V12 to the stage 2, you can see the computational cost there, whatever the number 2 represents, right? It could be distance, it could be cost, it could be anything. Okay. Not work there. Okay. Questions? Aditya, you had any questions? So far, so good, guys. Okay. In general, what are the characteristics of greedy algorithms, right? This is the paradigm. Okay. This entire slide deck is put together by combining a couple of other slide decks for your information. So you make a sequence of charts. So you are taking the current state. What have we done so far? Based on that knowledge, you're going to take the next step. Okay. The advantage is it's producing a smaller problem to be solved, because once you solve part of the problem, you ignore that. You only focus on what else remains to be done. Okay. That is the paradigm. Give me a second, please. Issue, let me know. Okay, in the meantime, I'll just continue unless somebody raises their voice and tells me they're not able to hear me, okay? Okay, so this is the greedy algorithm paradigm, right? So you make a sequence of choices, and each choice is the best based on your local knowledge, okay? Based on what you have done so far. Basically, you're narrowing down the problem, right? So once you solve one branch of the problem, you ignore that and you move to the next step. So that's how you're getting a smaller and smaller problem to solve, like going from source to destination, right? Okay, so far so good. So generally for this greedy algorithm to work, as I told you in the very beginning, right? As long as the optimal solution to the big problem contains optimal solutions in the sub problems, for this algorithm to function. Okay. Again, when you do some exercises on this, these things would become much clearer. Okay. Unfortunately, I would not have time in an online class to do exercises online for such a big class, but I'll send you some examples. So how do you design a greedy algorithm, right? This is the approach that we take to design a greedy algorithm. Cast the problem so that we make a greedy choice and are left with one sub problem. Somehow you have to prove that with the optimal solution, and your greedy problem gives an optimal solution to the original problem. The way it is listed here. Uh, for those of you who have some math bent of mind, this kind of shows that I come up with an algorithm, I try to prove its optimality. There's some kind of a proof involved in saying what you have chosen is the right way to do it. Okay. Now, the practical reality, guys, I must tell you, I know it's a theoretical class about these things, but I must tell you, there are a lot of engineers who come to work for this theory. Actually, some of them don't even know not learn. I'm just stating that as a fact. Okay. Now, there are some very famous greedy algorithms that are there. Okay. I will show some of them here. They're all listed in the slide deck. Couple of caveats here is these are not algorithms that I invented. Okay. Neither am I interested in knowing the gory details of it. But I'll give you some high level stuff, how people think. Okay. The intent of the next set of slides is to show you what kind of thought process goes into these algorithms. Okay. I may not be an expert in each authors who came up with the algorithm. Okay. So what is a knapsack problem? Very interesting problem, by the way. Okay. Very legitimate example where here we actually make our students go do programming, some of these things. So here is a knapsack problem. You all know what a knapsack is, right? The guy that guy who's carrying that bag, that is a knapsack. Think of it as your backpack, okay? Now, different items. Store has a lot of items, right? And each of those items, right? There's a certain weight and there's a certain dollar value. Okay. Now he is obviously there to rob the store. Now he needs to fill up that knapsack or the bag, okay? But he can only carry up to W pounds, okay? W means some weightage, right? He cannot take more than that. Now different items have different weights and different values. So how would he maximize the value of his haul? Meaning which of the items he's going to put them in the bag, so that way he gets the maximum value out of it. You all understand the problem? I'm pausing here for a second to show you all understood the problem. Straightforward. Ditya, I'm assuming you are able to hear me well now. Okay, great. No news is good news, right? Since nobody is commenting, that means you understand it. Okay. Now here is the thing. Let's go to the next step. Okay. When you talk about that knapsack, what it means is the variations, right? One is the item cannot be divided. Okay, you have to take the entire item or leave it behind. Okay. In the case of fractional knapsack, depending on the type of items, if they are, let's say, liquids in the store or powders, you can empty some of the content, right? And then put it there. We are not talking about that here. We're talking about all or nothing. Okay. In the case of fractional, partial items, okay? knapsack algorithm. Again, when we show these types of algorithms in a slide deck, it's a little bit challenging to understand them, right? You have to go sit down and write these things down on a piece of paper to convince yourself that this works. Okay. Sort items in decreasing order of value per pound. Okay, so you're decreasing order of value per pound, meaning you're looking at the dollar value there or rupees. Okay, and there, while still room in the maps, take as much as possible, all there is, or as much as will fit. Okay, that is the problem. That is the way it is done. So if you study that algorithm, there is obviously an n element sorted list, correct? And if you have an n element sorted list, and then you are doing that algorithm n times, and since it's a sorted list, sorted means you have some kind of a binary division, right? So you get big O n log n. Now, what is the big O? If you recall, what is big O? Big O is the the upper bound, right? Upper bound meaning, another way of looking at it, it is the worst case analysis. Okay, just to refresh your memory. Okay. Now, what is the best? Is it omega or theta? You can put it in the chat here. Okay. So here is the greedy 01 knapsack algorithm. So since you answered, so what is theta? I just put, you can put in chat. So here is a greedy knapsack algorithm, right? So realistic example. So you have item 1 weighs 10 lbs worth $60, item 2 weighs 20 and 100, item 3 weighs 30 lbs and 120. So somebody answered theta. Okay, so that's interesting. So they say it is SVW average, okay? Okay, I would not argue. Let's look it up. Yeah, it is between lower and upper bounds. You're absolutely right. It's really between lower and upper bounds. But most often the theta thing is used when you are able to clearly identify the primitive operations. If you're able to estimate the primitive, meaning it is really comes close to exact analysis of the algorithm. So I did put that notes in the cheat sheet that I uploaded, the notes. Okay, you're absolutely right, between lower and upper bounds. Okay. Whether you call it average or exact, I think it's basically it's like nitpicking the words, but you get the idea. Okay, going back to this, right? So how do we do this one here? Can anyone tell me how to solve this problem? So we have 3 items and I am the thief. Smart enough, right? If the thief is dumb, he would not be able to optimize his time in the bank. I think we can do a nice course on algorithms to would-be thieves. That'll be very interesting. Actually, if this problem can be explained to our politicians, that'll be more fun. They can optimize their stuff. Okay. So how do we do this one here? What is the solution here? Faculty members are welcome to tell me the solution. Tell us all, not just me, tell us all. If you want me, you want 50 LBs. So what happens if I were to take 5 of item 1? So that's 50 LBs. I'm going to make $300 worth, right? I'm looking for a solution, guys. Students, come on, you are much better than the faculty members. Sorry, faculty members, for saying that. Students are usually smarter than us, right? Let me give you another analogy here. Remember in math, when you're growing up in high school, how all these smart Alex, most of us, we need to take the highest cost per LB. Okay, when you take the highest cost per LB, highest cost is 6 LB per LB, right? And then, so your knapsack can hold 50 LBs. So 50 LBs means so your knapsack is full. So 5 times 50, right? 50 LB, 5 times, 50 LBs times 6, right? So you're getting $300. So Jntuk Kakinada said 220. Let's do a vote here. I heard 220 as an answer. Somebody said 240. I'm just putting things here. Any other answers? Plus, how did you get the 80? The 80 is what? So can you put it like item 1, then value total, and then item 2 value and quantity also. Item 3 quantity value. Okay, amount 300. Okay, the idea is you want to match. Okay, so that's what 300 isn't 300 the answer, but then we have different answers. We have a no. Shall we take a vote on that? Interesting, right? You see the students. I mean, this is all the reason why we. But and students, of course, right? Different people are giving different answers here. What is the goal here? Right? The goal is I'm greedy. I want to optimize. And I'm optimizing under the constraints, right? My constraints are I want maximum value for my money. Whatever I steal, I should have the maximum value. But I have three different answers here. Think about it. Here is a greedy strategy, okay? So what he did was in the algorithm, slightly different, right? They said, let me take the item 1 first. Okay. So the way we discussed was we said I can take items 5 of item 1, right? That was an assumption that I made. And I think some of you also made the same assumptions, like you can take multiple units of that same item. You is only one. What the slide deck shows here is, if you take, because that's the first thing that you took, nearest, whatever the case may be, then you said the next nearest is item 2. You take that too, okay? So you made $160. Optimal strategy would be set 220. Remember, they started with item 3, right? 30 lbs, 120 bucks, and then you still have room for 20 more, right? So you take the 20 lb one, that's $100, you get 220. So the optimal strategy would be 220, 160. You got it? Okay. JNTU, Kakinada, I think, and whatever you did there would work when you get into, I think, multiple unit. Okay. Okay. So taking item 1 is a big mistake globally, though it looks good locally. Locally meaning, what do you mean? I mean, you could argue, if I am an argumentative student, I would say, Professor, isn't the thief in the same room and aren't are all items in is not necessarily the most optimal. That is what the moral of the story here is, right? And we can solve this problem. I mean, we don't see any dynamic programming analysis and all that right now. There are other ways of solving the problem, okay? By end of this course, you would know about all of those things. Okay. Now here is a interesting thing here. I reduce the, okay, 1023. Chakravarti garu, I think about Huffman coding in electronics and communication engineering too, if I'm not mistaken. So this is a precursor to looking at Huffman codes. Again, I never considered myself an expert in any of these types of esoteric codes, but I do not have the audio. So let me see, somebody's putting something in chat. Okay. If you take 5 items of item 1, then we get 600, the 300 is maximum. More aim is to get maximum value only. Why is it made the wrong assumption there, right? We said 6 with 5 would give us the maximum 300. Okay, So going back to this coding, by the way, my video has come up now. I think because of the bandwidth, sometimes the video doesn't show up. Okay. Okay. In case you are wondering what I'm drinking, this is my green tea. Almost 18 hours today. 16 to 18 hours. Okay. So number of occurrence of each character you want to encode, and the goal here is the way you code this, called binary encoding of each character, is you want. So how do you do correspond to some letter? Okay. Now, if length prefix of another, as students here, I'm not, the intent is to tell you, understand the difference, right? This is just a way of telling you how to think, okay? In different ways. I'm not going to ask a question, tell me how Huffman code works. That would be an irrelevant question on my midterm exams. Now, how do you solve these problems? The way they do that is we use what is known as a binary tree representation. Remember we talked about binary trees in the last class, right? So here you represent that character, sorry. Okay, so for the fixed length code, binary tree is 0 and 1, right? There are only two branches, 0 branch, 1 branch. And at every place you have a 0, 1, 0, 1, 0, 1. Okay. What did we say other than the leaves, if everything is has 2 branches exactly? What did we say? It's like a full binary tree or something like that. We gave a specific name to it, right? Okay, and the number of occurrences of C times depth of C. So it gives you an algorithm here, how to come up with the cost of the code by following the tree from the root to the branches. Got it? Okay. Now again, you don't have to be experts in this, but you can see how he took a string of characters. He created a binary tree representation of each of those characters, A, B, C, D, E, F. So how do you get to A?